Ever get that feeling? Like the world's changing faster than we can keep up.
Yeah.
Well, get this. Today we're diving into a story about how melting ice in Antarctica could change, well,
Everything.
yeah, pretty much everything.
Pretty much.
We're talking weather patterns, the creatures living at the South Pole, even changes to the ocean currents that connect us all.
The whole system, really.
Right, exactly.
What's so fascinating to me here is that we often hear about climate change as this big, overwhelming concept.
Yeah.
But this deep dive, this gives us a chance to zoom in on a very specific phenomenon.
Okay.
The slowdown of the Antarctic Circumpolar Current.
The ACC.
The ACC, exactly.
And explore how it could have these ripple effects across the entire planet.
Yeah.
Okay, so the ACC.
Yeah.
For those of us who haven't been, studying up on our oceanography lately,
Right.
what is this current all about?
So the ACC, it's this incredibly powerful current that circles around Antarctica.
Okay.
And it's actually the strongest ocean current on the planet.
Really? Stronger than the Gulf Stream?
Way stronger, yeah.
Wow.
It acts like this massive conveyor belt connecting the Atlantic, Pacific, and Indian Oceans. It plays a vital role in moving heat, carbon dioxide, chemicals, even marine life all around the globe.
So it's not just some isolated thing happening way down south.
Oh, not at all.
This current is like the planet's circulatory system,
Yeah.
impacting the climate and ecosystems of the entire world.
Exactly, yeah. That's a great way to put it.
And the research we're diving into today, this fascinating article from the University of Melbourne,
Yeah.
they suggest that this crucial system is slowing down.
It is.
And the culprit,
You guessed it.
melting ice sheets.
So melting ice, slowing down a massive ocean current. How does that work?
Okay, so imagine you're pouring a giant pitcher of fresh water into a salty swimming pool.
Okay, yeah.
What happens?
It messes with the balance, right?
Exactly.
But how does that relate to the ocean? So just like that swimming pool, the ocean relies on this delicate balance of salinity,
Salinity.
the saltiness of the water.
Right.
Salt water is denser than fresh water,
Right.
and that difference in density is what drives a lot of the ocean's currents,
Including the ACC?
including the ACC. Yeah.
Okay, so the melting ice sheets are essentially like diluting the ocean water,
Yeah.
making it less salty and therefore less dense.
You got it.
Okay.
And as that surface water becomes less dense, it's less likely to sink. And that sinking motion,
Okay.
that's a crucial part of what drives those deep ocean currents that make up the ACC.
Wait a minute. So we're talking about a horizontal current flowing around Antarctica.
Right.
Now we're talking about vertical movement, too.
Yeah, it's all connected.
It's a truly three-dimensional system.
It is.
So like a giant underwater conveyor belt.
Yeah, think of it like that.
The sinking of dense, cold water near Antarctica
Right.
is what helps to power the entire global circulation system.
Exactly.
But as that water becomes less dense because of the influx of fresh water,
Yeah.
the whole engine starts to,
Sputter.
yeah.
It slows down.
So the melting ice is like throwing a wrench into the gears of this massive underwater engine.
A big wrench?
And they're projecting this could slow the ACC down by 20% by 2050.
20%. That's the projection.
It's not that far off.
No, it's not. It's coming up quick.
And the potential consequences.
Yeah.
They're pretty far-reaching, right?
They are, yeah.
For starters, we could be looking at more extreme weather events in certain regions.
Absolutely.
The ACC plays a critical role in regulating global climate patterns.
Uh-huh.
So disruptions to this current could lead to things like wilder storms, more intense heat waves,
Yeah, all that.
shifts in precipitation patterns.
Right. And it's not just limited to one area.
So we're not just talking about some localized changes around Antarctica.
No.
This could affect weather patterns across the globe,
Across the globe.
potentially impacting millions, even billions of people. That's right, billions.
And then there's the impact on global warming itself.
Yeah.
The ocean absorbs a huge amount of carbon dioxide from the atmosphere, acting like a giant carbon sink.
Huge, huge amount.
But if the ACC slows down,
Yeah.
that absorption capacity decreases, meaning more CO2 stays in the atmosphere, contributing to faster warming.
Faster warming, yeah, that's the
That's
concern.
right. So that's two major impacts.
Right.
More extreme weather and accelerated warming.
Two big ones.
And I'm guessing this also ties into sea level rise.
It does.
Coastal communities, major cities, they're all potentially at risk.
All the risk.
You're right to be concerned.
Absolutely.
Melting ice sheets are already a major contributor to rising sea levels.
Yeah.
But a disrupted ACC could exacerbate the problem in certain areas.
In certain areas, yeah.
Potentially leading to even faster and more significant sea level rise.
The faster and more significant, that's the worry.
This is where things start to get really interesting, I think.
Oh, yeah.
We've talked about how this slowdown could impact the climate and coastlines.
Right. But the ACC also plays a vital role in protecting the unique ecosystem of Antarctica.
It does. It acts as a barrier.
Barrier.
Yeah. Preventing invasive species from reaching Antarctica.
Oh, so it's like this exclusive club, Antarctica.
It is. It is.
With the ACC acting as the bouncer.
The bouncer. Yeah.
Keeping out unwanted guests.
That's a good analogy.
So we're talking about species that don't belong in Antarctica.
Right.
Things like certain types of kelp or even marine animals.
Uh-huh.
Potentially hitching a ride on the currents and making their way down south.
Exactly.
And as the current weakens,
Yeah.
the door to that club starts to swing open.
It does. It does.
We could see species from other continents arriving in Antarctica,
Right.
which could have major consequences for the delicate balance of the Antarctic food web.
Major consequences.
Imagine rafts of kelp from other continents washing up on Antarctic shores.
Yeah, I mean...
Or marine animals like shrimp and mollusks finding new habitats and outcompeting native species.
It's a real possibility.
And what happens to penguins if their food sources change?
Exactly.
Or the seals and whales that rely on a stable ecosystem.
It's a cascade effect.
This could have cascading effects throughout the entire food chain.
The whole ecosystem.
So how did the researchers even begin to unravel all of this?
Yeah.
We're talking about a massive, complex system that spans the entire Southern Ocean.
It's huge.
They must have used some pretty incredible technology.
They did. They used some of the most advanced tools available.
Like what?
High-resolution ocean and sea ice simulations
Oh,
run on Australia's fastest supercomputer.
wow. So they created a virtual ocean,
Essentially.
allowing them to study how changes in temperature, salinity, and wind conditions impact the ACC.
Exactly.
So this wasn't just some back-of-the-envelope calculation.
No.
This was serious science, using cutting-edge technology to model a truly complex system.
Absolutely.
But hold on a sec. I thought scientists were pretty sure the ACC was going to speed up because of climate change.
Yeah, some earlier models did predict an acceleration.
So what's changed?
So those earlier models often struggled to accurately represent the small-scale processes that are crucial for understanding the ACC's behavior.
Okay.
It's like trying to understand a complex machine by only looking at the big, obvious parts. You're going to miss a lot of the nuances.
Right, the finer details.
Exactly, the finer details.
So this new research, with its high-resolution simulations, was able to capture those finer details.
That's right.
And that's what led them to this very different conclusion.
It did.
So it's a case of better data and more powerful models leading to a more refined understanding of what's actually happening down there.
Absolutely, more refined understanding.
But this new research also highlights something else that's really important.
Oh, yeah.
The fact that science is a constantly evolving process.
It is.
We're always learning, updating our understanding, and refining our models based on new evidence.
That's right. That's how science works.
Well, we've certainly uncovered a lot to think about already.
We have.
We've learned about the ACC, how it's slowing down,
Yeah.
and the potential impacts on the climate, sea levels, and the Antarctic ecosystem.
All connected.
But before we go any further,
Okay.
I want to take a step back and ask, what does all of this mean for the listener?
Yeah, that's a great question.
Why should we care about a massive ocean current slowing down thousands of miles away?
That's the key question, isn't it? That's a great question. It gets to the heart of why this research is so important. What happens in Antarctica?
Yeah.
It doesn't stay in Antarctica.
Right.
This isn't just about penguins and icebergs. We're talking about a system that impacts the entire planet, including, the air we breathe, the weather we experience, the stability of our coastlines.
So it's not just some far-off problem for future generations to deal with.
No, not at all.
This is something that has the potential to impact our lives.
No.
Yeah, right here, right now. But if this slowdown has already happened, is there anything we can do to stop it? Or is it a runaway train at this point?
Well, it's not a simple fix, that's for sure.
Right.
But the good news is that we still have some agency here.
Yeah.
The extent of the slowdown and the severity of its impacts, they're going to depend largely on our future emissions.
Our emissions.
Yeah, and the researchers specifically highlighted the Paris Agreement,
That global effort to reduce carbon emissions.
Exactly.
It's a perfect example of how collective action on a global scale can make a real difference.
It can.
So it's not just about individual choices, like switching to energy-efficient light bulbs or driving less.
Right.
we need governments and industries to step up and make major changes too, right?
We do, yeah, absolutely. It's a multifaceted challenge that requires action at all levels.
All levels.
If we can curb emissions on a large scale, we can limit further ice melt.
Okay.
And potentially avert the worst-case scenarios for the ACC slowdown.
So there's still hope.
There is.
But I want to make sure I really understand the mechanics of this.
Yeah.
We've talked about fresh water disrupting the balance.
Right.
But the article also mentions something called
Antarctic bottom water.
Antarctic bottom water.
Yeah.
What's that all about?
So Antarctic bottom water is the name for the incredibly dense, cold water that forms near the Antarctic coast.
Okay.
And it sinks all the way to the ocean floor.
Wow.
It's actually the densest water mass in the entire world's oceans.
Wow. So it's like the super dense, super chilled water that kicks off this whole underwater conveyor belt system.
That's a great way to think about it.
Okay.
Yeah, and the formation of this Antarctic bottom water, it's absolutely crucial for driving that global circulation pattern we've been talking about.
So if the melting ice is messing with the formation of Antarctic bottom water, that's like a double whammy for the ACC, right?
It is.
It disrupts the sinking process and reduces the density of the water that does manage to sink.
A 1-2 punch.
Wow.
It weakens the entire system, and it all goes back to that delicate balance of salinity and density.
This stuff is seriously mind-blowing.
It is, isn't it?
It's amazing to think that something happening in this remote part of the world,
Yeah.
something as seemingly simple as melting ice, can have such profound effects on the entire planet.
It really highlights the interconnectedness of our planet's systems, doesn't it?
It does.
What happens in one corner of the world
Yeah.
can ripple outwards and impact us all.
Speaking of ripples,
Yeah.
the article mentioned that this research actually contradicts some earlier studies that suggested the ACC might actually accelerate because of climate change.
It's true, yeah. Some previous models did predict an acceleration.
So why the change in thinking?
Those models, they often struggle to capture the small-scale processes that are crucial for understanding the ACC's behavior.
The small-scale processes.
Yeah, it's like trying to understand a complex machine.
Okay.
By only looking at the big, obvious parts, you're going to miss a lot of the nuances.
Right, you're not getting the full picture.
Exactly.
So this new research, with its incredibly detailed simulations, is giving us a more accurate, more nuanced picture.
More accurate.
Like finally being able to see all the tiny gears and springs that make the whole thing work.
Exactly. The tiny gears and springs.
Okay, so we've got the science down.
We do.
We know what's happening, why it's happening, and what the potential consequences are.
Right.
But what does it all mean?
That's the big question.
What's the takeaway message for someone listening to this deep dive? It's easy to feel overwhelmed by all of this.
It is.
Like, what can I do?
Yeah.
It feels so big.
I think the most important message is that our actions have consequences, even in the most remote corners of the planet. What we do here today, it can have a significant impact on the delicate balance of the Earth's systems, even in ways we might not fully understand.
So it's not just about saving the penguins or preventing a few extra storms.
No, it's bigger than that.
It's about recognizing that we're all part of this intricate web of life.
We are.
And our actions can disrupt that web in ways that can have unpredictable and potentially devastating effects.
Absolutely. Unpredictable and devastating.
And it's not just about what we do as individuals. It's about pushing for larger systemic changes, too.
It is. Yeah, absolutely. And while the situation may seem daunting, this research, it also gives us a glimmer of hope.
Okay.
By understanding these complex processes, we can make more informed choices to mitigate the damage and protect our planet for future generations.
So it's not too late to make a difference.
It's not. It's not.
This has been a pretty intense deep dive so far.
It has.
We've covered a lot of ground, from the mechanics of the ACC slowdown to its potential impacts on the climate, sea level rise, and the delicate ecosystem of Antarctica.
A lot to think about.
But before we wrap up, I have to ask, what stood out to you from all of this research? What really grabbed your attention?
What really struck me was that image of
the kelp.
The kelp rafts, yeah.
Riding the currents.
Yeah, potentially carrying invasive species all the way to Antarctica.
Wow.
It's a powerful visual reminder of how interconnected our oceans are.
Yeah.
And how even seemingly small changes can have cascading effects across vast distances.
Yeah, that image definitely stayed with me too.
Me too.
It's a reminder that we're all connected, even to those places that feel incredibly remote and far away.
We are.
What happens in one part of the world can have a ripple effect on the entire planet.
That's right, a ripple effect.
It's funny how this deep dive started with us talking about melting ice and ocean currents and climate change.
Yeah.
But it's really become a conversation about the interconnectedness of everything on our planet.
It has, hasn't it?
Like pulling on a single thread and realizing it's connected to this massive, intricate tapestry.
That's a great way to put it.
It really highlights the importance of systems thinking, right?
It does.
We can't just focus on isolated problems. We need to understand how everything fits together.
Yeah.
How changes in one part of the system can ripple out and affect the whole
thing.
And that brings us back to us, the listener.
Yeah.
This might feel like a big, abstract issue.
I can see that.
But it really does connect back to our everyday lives.
It does.
The fate of the ACC, its impact on the global climate, and the unique Antarctic ecosystem.
Right.
It's ultimately tied to the choices we make.
The choices we make, that's right.
So what can we do?
That's the question, isn't it?
What's the call to action here?
Yeah.
It's easy to feel overwhelmed and think, well, what can I do to change this?
Absolutely. It feels so big.
So reducing carbon emissions is key.
It is.
Supporting policies and initiatives aimed at transitioning to clean energy.
Right.
Making sustainable choices in our daily lives.
Yeah.
Advocating for change. These are all actions that can contribute to a healthier planet.
They are. Yeah.
And maybe it also starts with simply staying curious, right?
You're curious.
Yeah, I mean, we wouldn't even be having this conversation if those researchers hadn't dug deep into this issue and shared their findings with the world.
That's true.
Sometimes it feels like the more we learn about the planet, the more we realize how much we still don't know.
That's the beauty of science.
Yeah.
There's always more to learn, more to explore, more to understand.
Right.
And the more we understand these complex systems,
Yeah.
the better equipped we are to make informed decisions about how to protect them.
This deep dive wasn't just about the ACC or even climate change.
No.
It's about empowering ourselves with knowledge,
Right.
recognizing our interconnectedness, and taking responsibility for our impact on the planet.
Absolutely.
It's about recognizing that our actions have consequences, even in those parts of the world that feel incredibly remote and far away.
Even in those remote places. Yeah.
Well said.
And perhaps it's also about embracing a sense of wonder.
True.
Yeah, the fact that we can study these vast ocean currents, model them on supercomputers and unravel their secrets, it's pretty remarkable.
It is.
Yeah. Well, I think it's time for us to come up for air from this deep dive into the Southern Ocean.
I think you're right.
We've covered a lot of ground today, and I have a feeling this conversation will continue to resonate with us long after we sign off.
I think so too.
And to you, dear listener.
Yes.
We leave you with this thought.
Okay.
What small changes can you make in your life to help keep this powerful ocean current flowing?
Yeah.
The fate of the ACC and ultimately the fate of our planet might just depend on it.
It might.
Until next time, keep exploring, keep learning, and keep asking questions.
And stay curious.